All right, welcome to today's class. In today's class, we'll be dealing on Pascal's triangle. A Pascal's triangle is a triangular arrangement of binomial coefficients where each number is the sum of the two numbers directly above it. Now, let me show you how to form a Pascal's triangle. All right, so let's call this n, and n is the power. So let's number it. We have 0, 1, 2, 3, 4, 5, and 6. All right, so we start with 1, 1, and 1. Now, note this. For you to form a correct Pascal triangle, it must start with 1 and end with 1. So here start with 1. And also, the middle term is the sum of the two terms directly above it. So 1 plus 1 is 2. So let's write 2 here. And then it ends with 1. This one starts with 1 again. 1 plus 2 is 3. So we write 3. 2 plus 1 is 3. So we write 3. And then it ends with 1. We start with 1 again. 1 plus 3 is 4. So we write 4. 3 plus 3 is 6. So we write 6. 3 plus 1 is 4. And then it ends with 1. It starts with 1 again. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So it ends with 1. It starts with 1 again. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then it ends with 1. So this is how you form a Pascal's triangle. You can see clearly that it has formed a triangular shape. That's why it is called Pascal's triangle. Now let's take an example on this. Let's expand x plus y all raised to power 2. So how do we go about it? Now note this. In solving this problem, the first term takes all the power. So the first term here is x. So we have x raised to power. The power given in the question is 2. So x takes all the power. And then the second term starts at 0. So y raised to power 0. Start from 0. And also decrease the power of the first term by 1 as it goes. And then increase the power of the second term by 1 as it goes until the first term gets to 0. So we have here plus x raised to power what? 2 minus 1 is 1. And then y raised to power 1 plus x raised to power 1 minus 1 is 0. And then plus y raised to power 2. So we'll stop here because the second term y has gotten to the highest power. So we have here x raised to power 2 multiplied by 1. Remember, according to the zeroth law of indices, which states that apart from 0, anything raised to power 0 is 1. So y raised to power 0 is 1. And then plus xy plus 1 multiplied by y squared. So here we have x raised to power 2 plus xy plus y raised to power 2. So the next task here is to apply the Pascal's coefficient. Now let's check for the Pascal's coefficient. Remember, in the question, the power given is 2. So n is equal to 2. So let's phrase it. When n is equal to 2, the coefficient becomes 1, 2, and 1. So when n is equal to 2, Pascal's coefficient is equal to 1, 2, and 1. So now let's substitute this into the equation. So 1 will multiply x squared, and then 2 will multiply the middle term, and then 1 will multiply the last term. So here we have 1 multiplies x squared plus 2 multiplies xy plus 1 multiplies y squared. So here we have 1 multiplied by x squared gives us x squared plus 2xy plus y squared. So this is our final answer. All right, so let's take another example. Expand x plus y all raised to power 3. So how do we go about this? First of all, the first term takes the highest power. So here we have x, which is the first term, raised to power 3. And then the second term starts from 0. So y raised to power 0 plus, we decrease by 1 for the first term and increase by 1 for the second term. So x raised to power 2 and then y raised to power 1 plus x raised to power 1 and then y raised to power 2 and then plus x raised to power 0 and y raised to power 3. So you stop where the second term has the highest power. So here we have x raised to power 3 multiplied by y raised to power 0 is 1 plus x squared y plus x y squared and then plus 1 multiplied by y raised to power 3. Here we have x raised to power 3 plus x squared y plus x y squared plus y raised to power 3. So our next task here is to apply the Pascal's coefficient. Remember, n is equal to 3. So let's find the Pascal's coefficient. When n is equal to 3, the Pascal's coefficient is 1331. So the Pascal's coefficient PC is equal to 1331. So now let's substitute into the equation. 1 will multiply the first term, 3 will multiply the second term, 3 will multiply the third term, and then 1 will multiply the last term. So here we have 1 multiplies x raised to the power 3 plus 3 multiplies x raised to the power 2y plus 3 multiplies xy raised to the power 2 plus 1 multiplies y raised to the power 3. So here we have 1 multiplied by x raised to the power 3 is x raised to the power 3 plus 3 x raised to the power 2y plus 3 x raised to the power xy raised to the power 2 rather plus y raised to the power 3. So this is our final answer. Alright, so if you are yet to subscribe to our channel, kindly hit the subscribe button, and also you can share this video to your colleagues. Thank you for watching.